Ever wondered how your toaster knows when to pop up, or how your garage door opens with the click of a button? It's all thanks to a little electrical workhorse called a relay. But what exactly does a relay do? And how does it work its magic? Let's dive in. Imagine you're a tiny, overworked electrician. Your job is to control a massive, high-powered machine. You could do it manually, but that's exhausting and risky. Or, you could use a relay. Think of a relay as your trusty assistant. It's small, but it can handle the big stuff. A relay is essentially an electrical switch controlled by a smaller electrical signal. It's like using a key to open a big, heavy gate. The key, the small electrical signal, doesn't have the strength to open the gate directly, but it can trigger a mechanism that does the heavy lifting. Let's break it down. A relay has three main parts. The coil, this is the keyhole. When you send a small electrical current through it, it creates a magnetic field. The armature, this is the mechanism that does the heavy lifting. It's a movable piece of metal that's attracted to the magnetic field. The contacts, these are the gate. When the armature is pulled towards the coil, it closes or opens the contacts, completing or interrupting the electrical circuit. So, how does this all come together? When you want to control a high-powered device, like a motor or a light, you send a small electrical signal to the relay's coil. This activates the magnetic field, pulling the armature towards it. The armature then closes or opens the contacts, allowing or blocking the flow of electricity to the device. It's like a tiny electrical magician, pulling off impressive feats with minimal effort. Relays are everywhere. They're in your car, your home appliances, and even your computer. They're the unsung heroes of the electrical world. But why do we need them? Well, there are a few reasons. First, relays can control high-power devices with low-power signals. This is essential for safety and efficiency. Second, they can isolate circuits, preventing electrical interference. And third, they can switch circuits rapidly, making them ideal for applications like automation and control systems. Let's look at some real-world examples. Your car starter is a classic application. Turning the key sends a small electrical signal to a relay, which then activates the powerful starter motor. Your garage door opener uses a relay to control the heavy-duty motor that lifts the door. Even your smartphone uses tiny relays to control its internal components. Relays come in all shapes and sizes, from small, single-pole relays to complex, multi-pole relays. They can handle different voltages and currents, and they can be used in a variety of applications. Understanding relays is essential for anyone interested in electronics or electrical engineering. It's a fundamental concept that opens up a world of possibilities. So, the next time you turn on a light, start your car, or open your garage door, take a moment to appreciate the little electrical workhorse that made it happen. With that said, thanks for watching, and until next time.